Yes, dear students, please see the other compound. It is given in the antimicrobials 1 topic. The next compound is bleaching powder. This is otherwise called as chlorinated lime. So you see the official name of bleaching powder is calcium hypochlorite. The chemical formula is CaOClCl. So it is prepared by passing chlorine gas over dry calcium hydroxide, that is always called as slack lime. You pass chlorine gas over slack lime, the temperature should be maintained very less than below 40, so that the formation of calcium chlorate is brought down. So we will get bleaching powder in this low temperature. So only one preparation. So calcium hydroxide, you pass chlorine gas, you will get bleaching powder or chlorinated lime. So assay, so like previous compound, this is also assayed by redox titration, but there we used potassium permanganate as a titrant. Here we will use sodium thiosulfate, Na2S2O3, sodium thiosulfate as a titrant using starch mucilage as indicator. The endpoint is disappearance of blue color. This is very important. You must write the titrant and the endpoint, right? So what is iodometric titration? So usually in the iodometric titration, iodine will be liberated. The liberated iodine is determined by titration against sodium thiosulfate using starch mucilage as indicator. Clear? So the liberated iodine with the starch, it will give blue color. So after the addition of sodium thiosulfate, all the iodine will be reacted with sodium thiosulfate. So if all the iodine is reacted to sodium thiosulfate, there is no iodine. So the blue color, iodine with starch will give blue color. So in the end point, the blue color will completely disappear, right? So the physical chemical properties of bleaching powder. So you know bleaching powder is a grayish white granular powder having a water of chlorine. When it is exposed to air, it slowly decomposed into calcium chloride, right? So this chlorinated lime or bleaching powder is used as a disinfectant, right? It is used for used in the purification of drinking water, and also it is used in the wells, drainage and latrines as a disinfectant. It is also used as a bleaching agent, so mainly in the cotton and linen fabrics, cloths will be bleached by using this bleaching powder. So two compounds, one is bleaching powder, another one is hydrogen chloride. We have studied the assay. So both are assayed by redox titration. One is permanganate, another one is iodometry. So next compounds, we no need to study the assay, only preparation and uses. Clear? See, if you see the potassium permanganate is another compound. So the preparation of potassium permanganate and uses properties is enough. So you know potassium permanganate is a powerful oxidizing agent we used in the titrations assay of permanometric titrations, right? So potassium permanganate is prepared from manganese dioxide. So manganese dioxide is fused with excess of potassium hydroxide in presence of air, an oxidizing agent to form potassium manganate, right? So either in presence of air or an oxidizing agent, we will get potassium manganate K2MnO4. That is, potassium manganate will be obtained. That potassium manganate is converted into potassium permanganate by either by oxidation or disproportion. So the equation is given here. You must write the equation for the preparation. So without equation, it's very difficult. The mark will not be given only if you write only the words. Even if you write the exact chemicals and how it is reacting, but without equation, they will not give the mark. So must write the equation in the preparation. So the physicochemical properties, the potassium permanganate is a dark purple crystalline solid. When it is a waterless, it is soluble in water. If it is dissolved in water, you will get a deep purple color solution. You might have seen in the titrations, in the permanometric titration, you will get a deep purple color solution if it is dissolved in water. So it is a powerful oxidizing agent. Everybody knows it oxidizes organic and inorganic substances and releases nascent oxygen. Right? Hydrogen peroxide is both, it has both oxidizing and reducing property, but KMnO4 is an oxidizing agent. It has powerful oxidizing property. So it is used as a disinfectant as well as antiseptic. It is used as an antiseptic in mouthwash and gargles. Right? So also it is used as a pharmaceutical aid. It is used as a titrant in the permanometric titration. So you can also mention it is used as a titrant in the permanometric titrations. Next, boric acid, H3BO3 is the formula. So boric acid in the preparation, the practical, we will see the preparation of boric acid is available. So this is prepared from borax, Na2B4O7. So borax is treated with either sulfuric acid or hydrochloric acid. We will get boric acid. It is obtained as a white crystalline solid. So if we cool the solution. So borax formula we must know. This borax with 10 molecules of water and hydrochloric acid or sulfuric acid gives H3BO3, that is boric acid. Right? Boric acid powder, it's very common. It is used in the dusting powder to heal the wounds. So it is used as a pharmaceutical aid in the boric acid ointment and dusting powder. It is used, and it is a local anti-infective. So externally, it is used to prevent the infection. So it is a local anti-infective. So it is a white crystalline odorless powder solid, slightly soluble in water and more soluble in hot water. It is also soluble in alcohol and glycerol. So physical property, just to write whether it is a solid or liquid and what is the color, odor, taste if possible. Right? So they will not give much importance for the physical chemical properties. The main is preparation, assay and uses. Right? See the next compound, this is iodine, is another important compound. The formula is I2. So it is obtained from laboratories from iodides. So potassium iodide with chlorine oxidation. So you will get iodide. So on laboratory large scale, the oxidation of potassium iodide using an oxidizing agent such as manganese dioxide and sulfuric acid we will get iodine, right? So there are two preparation. One is laboratory preparation, and the other one is from iodide. Clear? So iodine is used as an antiseptic and disinfectant. You know, the tincture of iodine is available in the market. So it is used uh, to kill the microorganisms in the wounds. So externally it is applied. It is also used as a disinfectant. So iodine is a source. So in case of thyroid deficiency, iodine deficiency in thyroid gland, so you have to take iodine. So it is a source of iodine for the thyroid deficiency, right? So iodine solution is also used as a titrant in the iodimetric titrations. So we have completed almost all the compounds. Only iodine preparations are available. The one is povidone iodine is another compound. It is prepared from iodine, and weak iodine, strong iodine, iodine solutions is also available. So that also we will see in the next class. Clear, students? If you have any doubt, please ask me.